Hey Opties! Today we're going to be talking about domain and range of functions. Let's take a look at the definition for domain. The set of all input values, also known as x values, that can exist for a function. So it's basically what are you allowed to have as x values? That's your domain. And it's the set of all of those x values that are possible. So if we're talking about what's possible, there must be some instance or some instances where you have some issues with what x value could be allowed. So there are two of these danger zones or domain danger zones here written. The first is a denominator. You cannot divide by 0. So you cannot have an x as a 0 if x is in your denominator. So that's one of the danger zones. Now it's not only 0, it's whatever makes the denominator 0. But if it's just an x in the denominator, then it cannot be 0. Another danger zone is square roots. You cannot have a negative underneath your square root. The reason why will be discussed in our quadratics unit, but for now, let's just remember you cannot have a negative underneath your square root. So if x is negative and it's a square root of x, then that's a big old danger zone for your domain. Here are some functions with no danger zones. So if it has no danger zone, then it has all the x values as being possible. So we've got any linear function. So here's an example, y equals mx plus b, slope-intercept. If you have y equals the absolute value of x, absolute value functions always have a domain that doesn't have any danger zones. Same thing for y equals x cubed, so our basic cubic function or our parent function for cubic. Y equals x squared, so our parent quadratic function. And y equals the cubed root of x. And this applies for any type of function in those function families. So no matter if it's a line that's moved here or here or here or here, same thing for your absolute value, your cubic, your quadratic, your cubed root. No matter where they're moved around, and that means no matter the transformation, which we'll learn soon, it will always have the domain as no issues or no restrictions. So there are three different ways to write a domain with no restrictions. The first is all real numbers. You can just write it in words. The second is this weird looking R symbol. If you're going to write it out, it's like an R with two sticks. This means all real numbers. It's just the symbol for it. And you can also write it in infinity symbols. So your x can exist for all x's, so it can exist for negative infinity to positive infinity, and this is called interval notation. Interval notation. An interval is not like an xy, like an ordered pair. It's just like x, x. It goes from this x to this x. Or when we talk about range in just a moment, it's going to go from this y to this y. So it's staying with the same variable. Here's an example of a function that we've talked about so far with the danger zone, and that's the square root function. Well, we just talked about square roots have a danger zone of a negative number underneath the square root. So as long as your x is non-negative, which another way of saying that is greater or equal to 0, then you're good. So we can say all x is greater or equal to 0, and we can write it in interval notation here. Now, this bracket, so we'll call this a bracket, when it's like, it's a squared off, it's a square bracket basically, and this is a parentheses, or parenthesis, if you're just doing it with one and not plural. The bracket means you're including the number. So including the number. And the parentheses, or the parenthesis, is meaning you're going up to. Going up to that number. Now, you always, always, always put a parentheses when you're talking about infinity. Because infinity is not really a number, it's just an idea. So you actually can't ever reach infinity. But let's say that you want to actually include the number 0, like we did here on the left. You're going to put a bracket. Now, why do we have a 0 first and then the infinity? Because we're going from the smallest to largest. Just like you're reading a book, right? Left to right. For our domain, we're going smallest to largest. And that's how you look at your x-axis anyway, right? So that's why you start with your 0, which is your smallest, and then you tell how big it can get. That's what the interval notation is all about. We can also write it as an inequality like so. We could say x is greater than or equal to 0. And this might be a little bit more familiar to you because we've already talked about inequalities. Let's take a look at range. The definition says the set of all output values, also known as y values, that can exist for a function. So domain is x values and range are the y values that are possible. So here are some questions you can ask yourself when you're trying to determine the range of a function. Does it have a top? So think about some functions that have a top, maybe a downward pointing arrow parabola, or an upside down absolute value, which would be negative absolute value of something. So if yes, then y is less than or equal to the top number. So this is always true if you have a top and it's going off of that top number, because that's as high as you get for your y values. That's why it's going to be less than or equal to that. Does it have a bottom? It's another good question. So is it like this? Or is it like this? That has a bottom. So it has a clear place that is the smallest y value you can get to. So that means your y values are going to be greater than or equal to the bottom number. So functions with tops, we've got y equals negative absolute value of x, so that's going to be looking like this sort of shape. Y equals negative x squared, which is like a hill, upside down u. And y equals negative square root of x, so that's looking kind of like this, and upside down arrow or upside down eyebrow, right? So y is less than or equal to 0 for these three particular equations. Now it could be different if you have some transformations, so some movement around on your graph. But if it's just these equations, then all three of these is y is less than or equal to 0. Because that's the point at 0 for y, so is this, and so is this. Okay, that's the y value for all those tops. So to write that in an interval notation, so this is negative infinity going downwards because we're talking about y's now. So we're talking about the y-axis. So instead of a negative infinity for a domain being this direction to the left, we're talking about negative infinity down because we're going to the negative or lesser y values. And the top is including the 0, so that's why we have a bracket. We can also write this in an inequality. Y is less than or equal to 0. Functions with bottoms. Y is absolute value of x, so that's an upward facing v. Y is x squared, so that's a valley. And y is the square root of x. So all of these have bottoms, and the bottom's y value is a 0. So y is greater than or equal to 0. you are starting at 0. That's the lowest you can go, and then you're going up from there, so you're going towards infinity with your arrows. Think about how your arrows are telling you you're going on for forever and ever. You can also write that as y is greater than or equal to 0. And functions with neither that we've discussed so far for our function families. Y is x cubed. So we're looking like this shape. So there is no restriction for your y's. It doesn't have a top or a bottom. Similar with our y equals the cubed root of x. Looking kind of like this. Remember, both the positive x cubed and positive cubed root both have the end behavior down, up. So your arrows go down, then up, down, then up. That's how I remember how to draw this sideways Superman here. Because sometimes I have a hard time remembering what that shape looks like. And then any line. Say y equals mx plus b, where m and b are numbers, right? M is your slope, b is your y-intercept. Here's an example of a line. It could be like this decreasing, so a negative slope. It could be a positive slope. But either way, there is no top or bottom. So this is just like your domain. All real numbers, this symbol for all real numbers, or negative infinity to positive infinity, but these are y's. And over here, these are x's. So it's still the same interval notation, but for domain, remember, talking about x's. For a range, you're talking about y's. So all real numbers for your x's over here for domain, all real numbers for your y's over here for range. Okay, that's it for our domain and range notes. See y'all next time.